Hi, hello, and welcome to everyone. Thank you very much for your participation on another webinar from Securiton. My name is Satya Seelan. You all can address me as Seelan. And I will be conducting the webinar for today. Those of you just joining, please kindly switch off your microphones and cameras as of for now to avoid all any distortions during the presentation. So without further ado, I'm going to start the presentation for today with the the topic of special fire. Sorry, guys, for a special fire detection for photovoltaic solar system. And for today's topic, we will be starting with the introductions of solar panel, and we will get to know insight of what is photovoltaic system, followed by a touch of code and practices and fire standards available concerning photovoltaic system. And later I'll also be covering on some of the fire incidents and the risk factors that associated with the photovoltaic installation and dealing with such an environment. And eventually I will go on to our system to explain the available system from Securiton to capture such issues, to address those issues, and to come up with a solution for better protections. And eventually we'll do a small conclusion with the system. Without further ado, we'll go into the presentation. Let me introduce myself again. My name is Satya Seelan, and people usually address me as Seelan. And I'm within the Securiton organization for the almost 13 years. Based in Malaysia and taking care of Asia Pac, and as well as Middle East, Africa, and certain countries around the world for all the technical support. Some of you guys already know me as well. So here, this is a good chance for us to indulge again during this pandemic with this webinar. If any questions are there, you can also raise during the presentation, or you can also write to us some questions and we can also answer you guys back. Okay, so let's move into our presentation for today. We're talking about photovoltaic systems, so it is actually a renewable energy. But when we talk about what is renewable energy is an energy that has been derived from Earth, from natural resources, and they are not finite, which means it's not limited, and it can be reused and renewed. A simple word is reusable energy, which is taken from Earth itself, such as the wind, the sunlight, and the biomass energy. So the many countries around the world now, they are seeking towards the renewable energy because it's not harmful to the environment, and the resources are always available and can be continuously used. Alternatively, as you know, before this, we have traditional energy that has been released from the fossil fuels and tend to be much or less harmful, but to the environment, if you're using the renewable energy. Hydroelectrics, for example, as you can see, is also one of the non-harmful, but the preparation in the hydro, it's actually causes a lot of hazard to the environment. But if you see solar in the other way around, it causes less harmful towards the environment. So most of the people around the world now moving towards a renewable energy. There are few renewable energies now which people are looking into. One of it is solar system or the solar energy, the wind energy. Mostly, if you've seen in most of the European countries, they have the wind turbine to generate electricity, and followed by some of the Southeast Asian countries and Asian countries, they have the biomass energies as well. So these are those energies which are used. So our focus for today will be based on the solar energy. And we use the solar panels, as some of you guys have have seen this, and to generate electricity and to be used in commercial as well as industrial and housing as well. So with that, we need to understand what is photovoltaic systems in the first place. A photovoltaic basically is a device that generates electricity directly from the sunlight via an electronic process that occurs naturally in types of material called semiconductor. So there's a semiconductor behind the rays or the glasses that you commonly see anyway on the top of the buildings which you see the solar rays. So the mechanism inside this ray would normally be an electron of these materials are freed from the solar energy and can be induced to travel through the electrical circuit. Eventually that makes a conversion into a direct current. So the direct current, eventually you have all the mechanism involved to change to an AC, which is normally alternating currents, which is used sending electricity to the grid or to the next usage of us. So the solar system can be as small for housing as well as huge as a grid section, also electricity. So it can be in a small residential outfit or can be also in a large photovoltaic stations that can be in a farm or in a huge area of manufacturings as well. So these are the applicable of solar photovoltaic around the world now. And as you can see, a solar system is being prominently a renewable energy. So it captures huge markets in terms of many countries who want to practice sustainability approach, which they wanted to make sure. There are a lot of European countries as well Asians are moving towards renewable and sustainable process, which means which not harmful to environment. At the same time, it's reusable, which also comes with a huge initial investment to build such solar energy facilities. So it needs a lot of space, and there's a technology behind involved, and there is a lot of money involved. Since there's a lot of that's millions of dollars are spent on the huge constructions and investment on this, so there's also a huge factor of fire incident or any other damages that can cause, which leads to the revenue lost. So these are the possibilities can happen because you put a lot of money towards the construction. So you need to make sure that it's protected at the same time. It is capable of ongoing. So we need an early detection system to prevent any casual towards the system. So need to stress here that the only way to capture this incidence of solar rays at the moment is only by humans view. So if anybody is walking through the grid area, they can observe the fire incident and they can report towards it, or any cameras or recording facilities available at the site. Those are the only possible ways to capture what is going on the site. So it's putting into a huge risk of early detection is probably not possible if you don't have a right system, or if you're depending purely on humans and cameras to capture those incidents and being reported. So that's where we're going to explain on how probably we can use the best techniques and insulation to prevent the losses to becomes even greater. With that note, I'm going to explain what are the code and fire practices and standards available around the world that useful or used to in order to relate with the installations of the photovoltaic system. So around the world, as you know, there are two major factors are influencing those standards, which is the American way or the Europeans way. So if you look into here, I've collected some of the standards which is widely used, which is NFPA. Under the NFPA codes, there are NFPA 70, which is National Electrical Code, and the NFPA MTB, which is Recommended Practice of Electrical Equipment. You can cross-check on the Chapter 33, which is mostly related to solar installations as well. NFPA 70E, Standards for Electricity Safety and at Workplace, and the NFPA 500 for the Building Construction and Safety Code. In terms of the Europeans, before I go to the Europeans, we also have the UL 3741 safety standards. Basically, the standards only talking about the evaluations of the PV hazard controls function. So mostly all the standards which is shown here are talking about how the installation shall be carried out, what are the best practice to install it, and how to prevent a fire incident to happen. Those are most of the standards which have been derived from here. So even the UL 341 is also mentioned about the hazards and control function. They never talk about the perfect fire installation. So there are still a lot of lack of studies or standards which actually talking about solar protection. Okay, but and see incidents are there, which I'll explain in a short while. So there are incidents happen. So if you look into also, there's a French standards available and also a BS standards available. They all talk about quite the same thing, which how to prevent the hazards towards installing and make sure that there is no fire incident happens. So in terms of fire prevention, still the early stage, there's no specific standards available towards capturing the fire incidents in solar systems. So with that note, before going there, I also like to mention, see, these are the major components of standards available around the world, but kindly check also your local codes and standards, because most of the countries, they also have their own standards. For example, in Malaysia, we have to cross-check with our local standards in terms of installing of fire rays, in other words, the solar rays on the building, because we are also in the countries which is one of the prominent countries using solar as a source of electricity. So with that note, I'll go into some problem statement here where we discuss about the types of issues and incidents that have happened before or also happened recently that can capture our interest, why it is such, see, the standards are not so intact with the insulation, but we still need to know what are the hazards involved with the insulation. But before going to the risk, we need to know the types of solar systems available, photovoltaic systems that are available. There are a few available, which is the ballasted rooftop, the penetrated rooftop, and the ground mount parking canopies, as well as the building integrated. So if we talk about the ballasted rooftop, as you can see on your right, there is a picture I mentioned. This is a common one you probably have seen in most of the buildings. It's a bit lifted up, and the solar is on the top of the building, capturing towards the sunrise and able to convert this. So there's a lot of mechanism there. The huge one, you will have certain numbers of rays and rows available, and there's a cable trays involved below, and there's a lot of insulations are also involved in this. And in terms of the penetrated rooftop, yes, you can also see this is basically mounted on the roof itself. And the ground mount, as you've seen, is mostly is a huge electricity grid areas, which used on the ground, and as well as the parking is almost the same as the roof, but it's on the parking bays, which places where already have parking bays, they will have the canopies raised on top of the canopies. And of course, it's already building integrated, because as you see in Malaysia and certain countries in Asia, we have the eco-friendly buildings, which already built with such solar rays as the mechanism based for the building on the roof as well as on the windows as well. So these are getting more comments also lately. Let's see what are the issues here on, for example, ballasted rooftop. Obviously, the weight is it's a huge weight on top of it, and the conduit wires are there. The cable trays are running on it, and it produces an accelerated roof collapse can happen that can also cause a fire incident. So there are possibilities that happens when you have cable trays. There are possibilities that their fire capturing can happen. In terms of the penetrated rooftop, it's a huge weight on it. If the fire thing happens, and the spreading of the fire towards the roof and towards the other components from the roof, it's also higher. In terms of the ground, as you can see, when it's mounted on the ground, there are a lot of vegetables, and there are fire hazards can happen because of the bees and wasps, nests and snakes, which is started to build, and this can be life-threatening towards the cables which is running below and can capture fires as well. There's incidents that so happens on that. So these are the issues that you actually see when you have installations of fire. Sorry, when you have the solar rays on top of the buildings as well as the areas which is covered. And what do you see? There'll be a risk of fire. So this risk of fire usually starts with the short circuits, the maintenance operation itself, the roof debris as well, animal nests, which I just mentioned just now, physical damages, and the panels getting overheating. See, the panels overheating is one of the most common things can happen. Yeah, this is also called hotspot. Whereas if you've seen the solar panels during the lines, when there is debris on top of this panels, and certain part of it getting higher heats and the certain parts getting lesser heat, and it gets a hotspot area, which due to the non-uniform powers redistributed, when the non-uniform happens, there is a chances that the triggering of fire can also happen on the PV cells. So this is also documented recently on one of the fire incident, and which can also ignite nearby materials, flammable materials if it's there. And so as you can see, this there are risk factors involved when you have a solar on the rooftop, and as well as the electrical systems, and these problems can even cause arcs between the conductors and grounds, and especially the hotspots. So the risk is quite high. And with that risk, let me show you a few incidents that happens around the world, which can open our eyes towards the incident that been there for a while. So I've collected some of the information, so incidents from 2009 up to 2013, which is mainly in the US, which is documented, so it's easier for me to derive this information. As you can see, the fire did penetrate to metal roof deckings, and two separate fires were started by the blind spot and the ground fault and the absence of DC disconnect switches and the combiner boxes, and it created an issue in terms of damages. So you see the structures, 30,000 meters square structures was destroyed in one of the fire in 2013. And if you see in 2014 in Germany, there's the damages of a few thousands of euros. It's also it's a warehouse. And in 2013 as well, there was another factories in Germany, which is also extended from the roof structure, and it collapsed as well. And also I've collected one more set of sticks from the Germany itself. The costs, and mainly because of the module, it contribute 12% out of it. And most of the inverters and power electronics, you see, those are the highest contributor, which contribute 25% out of the total lost as well. And terminal connectors and terminals, which is also caused fire incidents. This survey was done from 1995 up to 2012. So you see, the most common factor was the inverters and electronics devices. So we need a special care for those areas, which I'll be addressing in my solution in later part of it. And whereas you can also see junction boxes have contributed 90% of the total loss as well. And the AC and DC switches also contributed, not significant, but there is amount of failures which has actually caused a fire incident, which is around 8%. And I would like to share one of the recent incident which has happened this year itself in Netherlands, whereby this fire incident happens in a small town, yet the catastrophic is quite huge impact. And you see, it was recently happens in May 20 to 2021. And the causes, you can see a small picture below, the debris which fly or move around actually went up to, there are 73 notifications from the residents saying that this presence of the PV modules and the fragments were in their properties. And this is sharp, as you can see. So this damages can cause a huge impact on humans as well. So even the fire, during the fire and the process of the issues of fires are quite drastic. And we need to address this in a very early stage so that it doesn't cause any major problems towards the end. That note and the information that I've shared with you guys, we need to get a solution for such problems. To address those issues, we have our linear heat detection solution from Securiton, which I'll be sharing it into. Before I share with you guys the solution for such systems, I would like to stop for a while and to ask if any other questions in between of this before I go into the session.
So we don't have any questions, Seelan, from the attendees, but I've got some questions that I would like to ask you.
Okay.
One of them is, in the solar project, do we need protection for both cable trays and the solar array panels?
Yes, we do. And about the explanation, I'll be shortly giving in the next presentation to address this issue. Yeah.
Another question is, why is it not advisable to place the sensor cable on top of the solar array panels?
Okay, so which I'll be explaining in a short while. And this is why is because there's difficulties during the maintenance as well as to install on top of the fire sun rays as well. So it is easier to maintain if it's below the panels. So easy access is possible, the first thing. Second, issues is we do not need on the top to capture the fire. We have the protection around the cable, which can also penetrate below as well. Okay, so that is not necessary to install on top of the panel to make it difficult for them to do maintenance. That's also one of the reasons.
And
okay.
In case we have large solar array panels, are more controllers needed? Can we group them together and view at a centralized location?
Oh, yes, we can. I'll be also explaining in a short while. So that we have multiple devices can be connected, or multiple sensors and processors, which can be grouped together and view at a central station to get all the information in one location.
All right, we don't have any further questions at this stage, so you may please continue.
Okay, perfect. Thank you. Good. I'll proceed with the presentation now. I'll show you guys with some of the components which is involved in the PV system. In general, the building mounted PV installation will have a few things, which is the PV panels itself. There's the rays on top of the building, and obviously there's a cable, so it converts the electricity and it moves to a DC isolators, which converts the DC or stabilize the DC, or they also call it as a filter modules. And from the DC isolator, it goes to an inverters, which converts the DC power towards an AC. And again, it will filter up all the noises and all that we have in an AC and isolator. Eventually, it goes to a generation meter. Commonly in the houses, you can see a connection units and the energy storage, which is also sometimes called the battery backup. So to store those energy to reconsume or to reuse when the solar is fully charged. So those are those components involved here. So what we look into a protection obviously would be the PV array itself, of course, and the cable which runs, and as well. So here we'll look at the PV arrays as well as the cable trays, and as well as the components. As I mentioned just now, 25% of the casualties that happens is actually due to the DC and AC inverters and isolators, which is mentioned. So those components are also critical, which need to be addressed, though the significance is about smaller, but there is still huge impact on it. So these are the areas we will look into. How do we do the installation towards it? Here, a sample of how the installation can be carried out. The rate cables, as you can see, is our our SEC15 cables from the D list. And we have two zone systems. So the first, we can also divide it into a few sections, and you can run along the arrays of the solar. And below, as you can see, the sensor cable shall be mounted always below the solar panel. Advisable. That's a question was asked by one of the question asked earlier. Can we do it on top? I mean, it is not advisable on the top because you see, the induction and the penetration of the fire happens also around the solar area. So below the solar rays is also possible. So then we will always install the cables below underneath the photovoltaic arrays. And here the advantage would be we have two zones, so we can separate more zones. In fact, to address here is also our sensors are addressable. So we have sensor carved inside this SEC15 cable, and you can actually address this where is the exact location and which is the rays, because we can zone them up also during the programming, and we know it's the rack number 1, rack number 2, rack number 3, rack number 4, so and so forth. So it's always possible to address the racks of the arrays as well. And in terms of that's on the protection when we look at the arrays. Now, if we look into the cable trace which is running, as I said, from the arrays, then the PV arrays, it moves to the cables to the isolators. So before that, you must have lots of cables running through underneath the arrays, which you can have few methods of installation. The first is the suspended the center above the cable tray at the distance of 0.2 to 1 meter. So you can have it on the above trays, and you can also place it at the side of the cable trays. If the cable tray is already filled with cables and it's a bit intact, so you can also move it towards the end of the cable, or you can put outside as well. So these are the common things that you can install the cable. And a few methods also from us. You can also have a junction box if you see it's difficult to move around. And see the first two, you can see a red color box. That's actually a junction box to separate areas, and then they can be interconnected. So those are non-connected areas or non-protected areas. You can use a normal cable, and the connected areas or the protected areas shall be used with the SEC15 cable. So that's also possible. So those are the methods where how to run the cables on the cable trunch. Now, moving on to the third section, which I mentioned, the components I mentioned, 25% of the contributors are those DC isolators, the AC isolators, as well as the AC to DC converters or the inverters. So these are the fire incident contributors as well. Here, what we can do is we can use our external sensor. See, our D-lists are able to have a sensor SEC15 cable as well as external sensor cable. So these are the flexible cables which it's connected from the junction box towards the critical area. So what are those critical area here? We look at it here. First is the DC isolator, the DC and AC inverters, which as mentioned, and the AC isolator. So those are the areas which can also capture fire or produce fire incidents. So here you can run the cable and place it near the components or at the components itself. This is also called object monitoring. So you can actually monitor those critical devices and can prevent early stage fire. So these are the possibilities. If you use our D-list, we can have the raised solar protection. We can have the cables to be protected. Finally, we can also do special protections on the critical components. So with that note, I also like to mention a few more features that are available from our D-list, which can be helpful. As you can see, the most critical components here are the temperature. As you know, in certain countries, which is in Asia, are very high in temperature, and this temperature could be the causes of overheating and can produce fire incidents towards the facilities. So with that, we need to do a temperature monitoring, and with that temperature monitoring, we can do a cooling system. So we allow the system to cool down and to protect the assets and the property from early damages. So how this is possible? Then we need to know exactly the temperature. So this can be done with our D-list, where our references temperature profile is available, and a real-time reading of the temperatures is also possible from each of the sensors which is located below the arrays. Okay, so that is how we can manage. So we are not only protecting the system for fire, we can also do a live monitoring of a temperature and associate it to another cooling system. If they want it, we can give the relevant outputs for it. With that note, I'll show you one of the example. Here, as you can see, when you have 4 or 5 number of tracks of arrays, then we can actually combine the track number 1 will have zone 1, track number 2, zone 2, and so on and so forth. And you can actually measure the temperature. Live temperature is possible. If you see the other market, the other competitors are using a normal temperature, or they have to use algorithm calculations to calculate the exact temperature. So it's actually a calculation temperature, a calculated temperature, which may not so accurate. But in our case, each of our sensors are actually producing a real temperature. So this can monitor, and when the threshold of certain temperature is prescribed here to be reached and also crossed the threshold, then we can associate the relevant relays from our D list, and that can actually tell the third-party system to switch on their cooling system. So that's also possible with our system. At the same time, need to mention also the external sensor works the same as well. So the SEC15 as well as the external sensor works perfectly in terms of capturing the temperature monitoring as well. And we also will face a lot of issues in real site installation. As you know, this is outdoor and it's on top of a building, and it can have a lots of fluctuation happens in cold climate countries or seasonal countries, as well as the normal countries like in Asia. We also will face the sudden increase and sudden drops of temperature fluctuation. This is a nature which we can't stop. So how do we solve this problem? So we have an automatic adjustment on a daily basis or in a constant basis. And this environment fluctuation are captured in two measurement. First is the current temperature, which is the current temperature is running, and a reference temperature. As you can see, the two lines here, the green represent the reference temperature, which checks throughout the cycle when he does a cycle check, that every time he cycle 1 time, 10 times of reading, and he capture the reference, and then he gets a real temperature. So if the fluctuation, it's not drastic, it happens in a slow manner. So it check, or he does the algorithm calculation between the reference and the real cycle, and will not eliminate any false alarm. So we will not have a false alarm due to environmental fluctuation towards the climate changes. So that already been eliminated with our system. So other features that our system has here would be also the rate of rise and as well as maximum alarm. So a sudden change, which I just mentioned, a sudden change happens in 1 or 2 sensors, then it's a sudden change. It also still checks with the reference temperature, but then 1 or 2 sensor may rise in short period of time, which is called rate of rise. And some countries, they call it differential alarm. So the differential alarm will be produced. At the same time, if you reach the maximum temperature, it also produces an alarm. So need to mention here, we also have pre-alerts as well. Yeah? So that means pre-rate of rise as well as pre-maximum alarms is available. And with the relevant relays that we are given with the delays, we also have 2 versions of delays, yeah, with the relays, onboard relays, as well as external relays, additional relays, sorry. With those relays, then we can actually give away all this information to the third-party system as well. Okay, so if you're not sure what should the best settings available, we already have a valuation standard that is based on EN 54-22. So with this, you have already a default thresholds available with the A1 end, A2 up to C end. These are the response classes according to the EN 54-22. Mostly it's talk about to layman people. So I will just explain. It's all about the more sensitive towards the less sensitive. That's how the A1 end to C end represent all about. So the adjustment of our sensors can be as accurate as sensitive as 0.1 degree increase that can be used as an alarm or a pre-alarms. So that's sensitive you can be. And the reference temperature is updated every 1 measuring cycle. So every 1 measuring cycles, it takes 10 seconds to measure and to find out what is the current temperature of all the sensors, and it will keep 1 measuring cycle, and it will correspond to the actual temperature, which has been fluctuating according to the environmental fluctuation or a real incident fluctuation. So that's how it's done. And you besides this evaluation standards from EN, you are also freely to assign your own temperature. Why I said about the EN 54, you already have predefined because this is tested according to regulation. So it's always safe to have a regulation standards being used. So with that, I'll go into what is the delays that we offer comprise of. So it's actually a temperature monitoring system. We have 2-zone system, or we call it 2 times 100 sensors, each of the lines that we can go, a maximum of 350 meters that we can go. So times 2 because of 2 sensor base, and 2 times general alarm and 2 general fault, which is on board. Pre-alarms available at default function by 90% and a maximum alarm at 50% or differential alarm. And up to 5 branches is possible, which I'll be explaining in a short while. What are the branches and what is significant about these branches? And there's already an interface available, which is RS232, RS485, and also a LAN connection, which can be connected among them and to be viewed into a central place. And the protocols which we give away would be a Modbus protocol. We have both protocols available in RTU as well as TCP/IP as well. And in terms of the number of controllers, one of the questions raised earlier was, can we group them up? Yes, up to 95 controller units can be networked into a graphical user interface using 2 connection methods. One is RS485 and the other one is LAN. So with this, you can able to have in a huge installation, for example, land grid arrays, which you may have a number of arrays available, and you may need more than one area, D-list to be connected. So it's possible to have 95 units to be connected. Okay, up to 32 zones are freely programmable for single units. It's possible, yeah. So those are the key points that our D-list has as well. So in terms of the cable, sensor cable that we have called the SEC15, and this, as I mentioned earlier, the sensor cable comes in terms of the spacing that the customer needs, or normally we call it the spacing distance between them. It comes with 1, 2, 3, 4, 5, 9, or 10 meter, or customer specify. There are certain countries we need 7.5 meter for certain application. Yes, it's possible to manufacture according to the need of the customer. Mostly we use the 7 meters because according to the norm, and the detections of area of each sensor shall be between 7 meters distance. So all the sensors are available according to the need of the customer, and it's a maintenance-free sensor cable. You don't have to maintain the sensor. If there's a faulty sensor, you can actually change those section which is faulty with the relevant repair kits, and you're good to go. You don't have to change the entire cables. If something happens to the sensor or damages up because of fire of certain areas, you don't have to change the entire cable, but only the affected areas. In terms of failure rates, we are extremely low. As you can see, the mean time between failure is approximately, the calculations given is approximately 68 years. If the maintenance, the normal maintenance were done and was taken care, shouldn't be any problems in terms of failure. And it's also EMC compliance, which is EN under the EN 50130-4. And to mention, this is also flame retardant cable jackets, and this cable, need to mention, is self-extinguished cable. Yeah, just to stress on this. If a real fire incident happens, people always have a query of, would this cable will propagate fire? No, it will not. So this materials is made in a sense of it is self-extinguished. We have done a few tests also in a real site to prove to customer when the fire incident happened, it becomes it shrunk into size, and it does not propagate fire. So that's also to be mentioned here. So this is fire protection. At the same time, it's the best protection not to propagate fire to other incidents. Okay. With that, there are a few methods of how we can connect those cables. First, as you can see from your left, you can see the D-list SU35, and the CC15 is a normal cable. The non-protective areas, you can use the normal cable running through the junction box, and from the junction box, you can run the actual cable of detection, which is the SEC15. So that's the first one. With the junction box, we also have connectors available, which you don't have to do additional work of connection. It is a plug and play type, which you can plug it in, and you can have the system between the non-protective area towards the protection area. And another method is we can also have additional junction box, whereby between the first grid area to the next grid area, so you may have a distance which you don't need a cable to run through. So you can have a junction box, and then you can have a CC15 or a normal cable connector, and you can continue to the second grids which are available with protection cable. So that's also possible. So that's the same method. You can use it. You can use it either with the junction box, or with the connectors ready cables as well. So these are possible. These are the possibilities that are available to do the connections. As I mentioned earlier just now, one of the flexibilities, we can also have branches. Of course, when we start having branches, it will reduce in terms of the distance that it can cover, but actually you can have 5 branches in total of 150 meter. So if customers are interested to zone it, I don't want to have more failures. So you can also have to have junction box, or in terms of flexibility, sometimes you don't want to run the same cabling throughout a few areas, and there's a restrictions in the grid that you cannot continue. So you can have a few junction box and you can run separately as well. And this is possible with 5 branches as the minimum requirements to run the system. Okay, good. So with that, I will explain about the insulation brackets, which is sold by Securiton as well. So these are the Click 15, the MDC is actually the steel type, and also the MDJ, which is it's wall mounted. So we have all the right accessories to be used to mount into it as well. Okay, so these are the components. And here I'll show you one of the sample insulation that we have in the real installation of photovoltaic, the PV system arrays. They are, as you can see, the fastening sensor cables and the polyamide clamps to mount on the profile, and the cables were running underneath the rays of the PV. So these are one of the samples which I've collected for you guys to have a look how the installations were carried out. And with that, I would like to explain about the advantage. As I said, the measuring cycle is always 10 seconds, so it always gives you a reference value to connect with the main actual reading, and this is compromised to eliminate false alarm. And the sensor spacing distance is freely selectable. As I said, if the customer needs to know, I need a very fast detection with every one sensor spaced on every arrays, is possible because we have 1 meter sensors apart, cables also available, and the individual sensor is identification of cable imprint. So every sensors are addressable. So you can actually, if you want to go into details, you can actually address every single PV race on the top of the building if you want to. If you don't want to have zones, you can even address every single race, which is it's for critical environment, for example. And generally the system is maintenance free. Low commissioning and maintenance cost, and the calibration is not needed. It's calibration free. You don't have to come back to recalibrate the sensors. They will measure every 10 seconds, so they're always been captured and seen the workability or the functions of the cable itself and the sensors as well. And the use of external sensors I showed you just now. So we have a flexibility to have from the main cable an external sensor cable to be on the object monitoring. For example, as I mentioned, the AC and DC isolators, which you can use as well. And it's resistant to dust, gases, as you now see, it's on the outdoor, rain and all the environment fluctuation will not do any damages to our system. So this can also be in X zones as well. We also have cables and processors which is certified under the X zones. If some of the grids are near the explosion area or dusty environment of zone 2 and 22, which is also possible from us. Okay, with that note, I also would like to mention the certificates for this approval. We have VDS approved product under the EN 54-22, which I also mentioned earlier. It was certified there. And we have the DNV GL, and we have RHS compliant, and we also ATEX approved. So these are the standard approvals and certificate which is available. The DNV GL are usually used in the vibration prone areas, which is the zone 2 and 22, where ATEX are also placed here. And this product is not so harmful, so that's the reason the RS compliance is also there. And I would like to conclude the presentation for today. So from us, we offer one of the unique system, which is the D-list, which can capture a few areas in the PV system. As you can see, we can do the arrays, the cable, as well as the object monitoring to capture the entire interest area of fire. And with that, the high flexibility of the design and LHD complete coverage for the entire PV system. And also to be mentioned is durable built and finished with daily to ensure this is uninterrupted operation for the entire system. Okay, that's all for today from my side and the explanation about the PV system. Hope all of you benefit out of this. And now I would like to pass it back to my moderator, Mr. Zach. Thank you.
We are conducting a survey today which will help us to improve our webinars. We kindly ask you to fill in the survey form. Your feedback is highly appreciated. You can also copy the link for later answering. This would help us a lot. Thank you very much. Getting back to the question, Seelan, what would be the bending radius of this sensor cable?
Okay, perfect. So as you can see from one of the pictures I've seen shown earlier, so it can run on the on a symmetrical matter, and eventually it has to bend. And this bending radius shall be between 23 centimeters up to 30 centimeter radius to avoid try to avoid a 90-degree bending, because you have sensor cables at a certain intervals. So you have to make sure, as long as between the 23 centimeters to approximately 30 centimeters, shall be no problems.
The next
Good. Any other questions?
Besides fire signal detection, can it also measure real-time temperature?
Yes, it does. As I mentioned earlier, one of our key point here is also, besides fire detection, each of every sensors are capable of measuring their own temperature. So those temperature can also be derived into a mode bus, and the signals can be sent, a live signal information, or we call it live value, can be converted into a mode bus and given to the third party to view as a monitoring system as well, temperature monitoring system. Yeah, it's possible.
So we have some questions from the attendees, and one of them is, which class PV solar lies?
In terms of the class?
Yes.
Okay, I'm not sure I get this question in terms of class, but normally we go according to the standards from EN 54 to EN 22. So whereby it can be installed in anywhere where the heat is an issue. The heat is the first stage of incident. So whereby LHD shall play the role of insulation. So in terms of classes, I'm not quite sure about the classes here. Yeah.
So the next question is, how about this cable immunity with EMI or RFI?
Okay, so this I've addressed earlier. So this has been stringent check with the during the production, where we have the EN certification for EMC interference. So we shall not have any interference toward the EMC. That's the reason also we can run along the cable trace as well, and on top of the cable trace, which you have the high voltage cable running on, which is AC and alternating, should not have any interference in terms of the EMC, which will fluctuate in terms of the readings.
The next question is, and the UL certification is in the pipeline. Do we have it? Are you getting it in the next months or something like that?
I have to cross-check with my relevant department, because it's the process is still ongoing. So I have not given a final word about it. So I have to cross-check, and this information will be given by the respective sales representative of each countries, and probably when it's available or it's in the process or whatsoever, shall be given in due time.
Yeah, and the last question that we have is, what is the ambient temperature of sensor cable?
Okay, the ambient temperature, the working condition temperature, or the ambient that he reads. Okay, so probably I'll just answer in general. As you can see, when you install, during the installation, you need to take some precautions, because you should not install this cable. There are countries in the northern hemisphere whereby cold countries which you have minus temperature during the installation. So anything below than minus 10 degree, you should not install such, because it becomes brittles and it's not advisable to install. So you should install the system during a normal working temperature, which is above 0 degree. And it measures the current ambient temperature, because as I mentioned earlier, there is a reference value which detects the current ambient temperature and cross with the fluctuation temperature. So that's how the system works. and about the installation, as I mentioned, shall be installed in certain temperature prescribed by Securiton standards. Any more questions from you, Zach?
No, we don't have any questions at this stage. So if we don't have any questions, we will close the webinar in about 2 minutes time.
Perfect. Good.
So we'd like to thank you, all the attendees, for attending the webinar. Thank you very much. And we look forward to seeing you at our next webinar. That's a valve hall fire detection, the case for HVDC, which is scheduled for the 16th of December. And invitations will be sent to you soon. Thank you, Seelan.
Thank you so much. Thank you, everyone.